Hello students, in this video I am going to teach you objective questions from complex numbers, chapter number 2. Complex numbers, one of the very simple topic. Try to understand all the concepts, then you can do the sums very easily. While doing this objective question, I am not only just solving the questions, I will explain all the concepts behind that. So that after solving all these 25 questions, I am sure you can answer any question in complex number. Okay. Since there are 25 questions, I am going to take this in 2 videos. Okay, in this video, I am going to teach you first 15 questions. Okay, so the basics of complex number, here I is there, right? I is equal to, what is I? Root of minus 1, right? I equal to root of minus 1. I square is equal to minus 1. Then some of the important values, I raised to 4 is 1. I raised to any force multiple. So I raised to 4n. Your answer is what? 1. Okay, that you remember. Then continuously if I take 4 values, for example, say I raised to 1 plus I square plus I cube plus I raised to 4, then your answer will be 0. Why? I raised to 1. It is I square minus 1. I cube can be written as I square into I, right? I square is minus 1 into I, so it is minus I. I raised to 4 is 1. So you can cancel plus 1 minus 1 plus I minus I, so your answer is 0. So remember, continuously if I take 4 values, 4 powers, okay, continuously I raised to 20 plus I raised to 21 plus I raised to 22 plus I raised to 23, then definitely your answer is 0. You start from anywhere, continuously 4 powers you take. Okay, so that you remember. Then 1 by I value is what? Minus I. Okay, so these are some of the important values. Okay, now we start with question number 1. Look at the first question. I raised to n plus I raised to n plus 1, the next number, right? Plus I raised to n plus 2 plus I raised to n plus 3. 4 continuous values, then you know the answer is what? 0, the first option. Okay. Now let's move on to the second question, similar to that, but little lengthy one. Okay. Sigma means what? Summation. Sigma I equal to 1 to 13. So first for I you give 1, then you give 2, 3, 4, etc. Up to 13 you give. So you will get 13 set of values. Okay. First we give 1, when you give 1, I raised to 1, I, plus I raised to 1 minus 1, I raised to 0, any number raised to 0 is 1. So this is the first set, plus, now we give the second value, 2. When you give 2, I square, right, plus I raised to, for n you are giving 2, so 2 minus 1, it is 1. Now we give 3, I cube plus I square, plus etc. Then finally, you have to give the last value. The last value is what? 13. When you give 13, I raised to 13 plus I raised to 13 minus 1, 12. So there are 13 set of values. Each set there are 2 numbers. So what I am going to do, first we take the first numbers alone. We take the first numbers I plus I square. No need to simplify, right? I square. Next I cube plus etc. The last one is I raised to 13. Of course, you know the previous one, you would have got I raised to 12. Then previous I raised to 11, like that, right? Plus, now we take the second values. You take the second values 1 plus I square plus I cube, etc. It goes on. The last one is what? I raised to 12. Now use the same concept what we studied now. Continuously 4 values, 4 powers you add. The answer is what? 0. So I start with I raised to 1. 1, 2, 3, 4, 0, right? Then 5, 6 up to 8, it is 0. Then 9 to 12, again 0, right? So 1, 2, 3 continuously up to 12, 0 plus 0 plus 0, right? It is 0 only. Only one term left out. What is that? I raised to 13. Plus, see the second one, you start from the second number. I means I raised to 1. Sorry, here I square, right? I plus I square plus I cube, etc. up to 12. 4 you take 3 times, right? So that part is again 0. So your answer is only the first term you are getting 1 plus 0. So it is 1. So this is your answer, right? But I raised to 13 can be simplified. I raised to 13. Nearest 4's multiple, I raised to 12 into I raised to 1. I raised to 12 is 1. 1 into I. So the answer is what? I. So I plus 1. So that is option number 1. Now let's move on to the third question. Listen carefully, the third one. The area of the triangle formed by the complex numbers. Area of the triangle formed by the complex numbers. See, 3 complex numbers given here. The first one is Z, second one is IZ, third one is Z plus IZ. Listen, Z and IZ. So when you multiply a complex number Z by I, it takes a rotation of 90 degree in the positive direction. In the anti-clockwise direction, it makes an angle of 90 degree. 90 degree rotates, okay, through the origin. So the angle between Z and IZ is what? 90 degree. So you know this is a triangle, they said. So you know it is a right angle triangle. So among these two, one you take it as base, another one you take it as height, because here only the angle is what? 90 degrees. So area we want to find. So area is equal to half into base into magnitude. You take modulus Z into height IZ, right? So half into modulus Z into, you split into 2, modulus I into modulus Z. Modulus I is 1, so 1 into modulus Z. So your final answer is half into modulus Z into modulus Z. It is modulus Z square. Okay, so third option is the correct one. Now look at this question. The conjugate of a complex number. See, suppose Z is a complex number, Z is a complex number, A plus IB. Then conjugate Z bar. Z bar means you change the sign of imaginary part, right? For I, you put minus I. Change the sign. So A plus IB, then Z bar is A minus IB. What is modulus of Z? Modulus of Z means root of A square plus B square. Modulus of Z bar, if they ask, root of A square plus minus B square. Minus B square also what? B square only. You will get the same value. So you know modulus of Z and modulus of Z bar both are what? Same. Then Z1 by Z2. If I want to take the conjugate, you can take separately Z1 bar by Z2 bar, right? For numerator take separately, denominator you take separately. Okay, now look at this question. The conjugate of this complex number. So this is of the type modulus Z1 by Z2. Sorry, not modulus, conjugate, right? So Z1 by Z2, the whole bar. Numerator, denominator is there, no? You can write Z1 bar by Z2 bar. Please listen. Z1 bar, numerator conjugate, one conjugate, one only. Denominator is I minus 2. So denominator you are getting I minus 2. The conjugate is, you change the sign of imaginary part, change the sign of imaginary part. So what you get here? So you will get minus I plus minus 2, right? Change the sign of imaginary part. Minus I minus 2. Don't change the real part, okay? It is not mere change sign in the middle, no. So you have to change the sign of I, okay? Change the sign of imaginary part. So take a minus sign outside. Minus 1 by I plus 2. Minus 1 by I plus 2. So the correct answer is the second option. Listen the fifth question. Find modulus of Z. So this is Z. They asked to find modulus of Z, right? So you take modulus of every term separately. So modulus of, modulus of Z1 into Z2 by Z3, that type this one, right? You can write modulus Z1 into modulus Z2 by modulus Z3, provided the denominator not equal 0, right? So when you take modulus, first you take the modulus of this part alone, then you take whole cube. Modulus of this is root of A square. A square means root 3 square. It is 3 plus 1 square is 1. The whole cube is there. Next you take the modulus of this part, root of 3 square 9, 4 square 16, the whole square is there. Denominator, find the modulus of this part, then you take the whole square, right? So when you take modulus root of 8 square 64 plus 6 square 36. Now just simplify this. 3 plus 1, 4. Root of 4 is 2. 2 cube, it is 8. Like that you simplify. 9 plus 16, 25. Root of 25, 5. 5 square, 25. Denominator, 64 plus 36, 100. Root of 100 is 10. Square is there, so 10 square is what? 100. Cancel by 25 table, you are getting, denominator is what? 100, right? Cancel, you are getting 4. 4 table you cancel, you are getting 2. So the answer is 2, option number 3. Now, listen to the 6th question. If Z is a non-zero complex number such that 2I Z square equal to Z bar, they asked to find modulus Z. Please listen carefully how to do this. Taking modulus. When you take modulus, 2 modulus is 2 only. Modulus of I is 1. Modulus of Z square, right? Right side is modulus Z bar. We take modulus for every term. So 2 into modulus Z square is equal to modulus of Z bar and modulus of Z both are same. So cancel 1 time modulus Z. So 2 modulus Z equal to 1. So modulus Z is equal to 1 by 2, right? 1 by 2, that is option number 1. Now the next question, please look at this question. If modulus Z minus 2 plus I less than or equal to 2, then the greatest value of modulus Z. So this type is very important, not only for objective questions, for 2 mark, even 5 mark questions are there. Greatest value, least value, right? There are some easy methods also. This is a direct question, so we'll use the result what you studied in from the book. So we have a result. Modulus of Z1 minus modulus of Z2, the whole modulus we take, less than or equal to modulus Z1 minus Z2, less than or equal to modulus Z1 plus modulus Z2. Okay, so this is one result you have to study. So here no need to give outside modulus because we are adding 2 positive values. But here you are subtracting 2 positive values, so it may be positive or negative, right? So that's the reason outside the modulus is there. So this is the least value, this is the greatest value of this, right? Now listen how to do this question. See what they asked. If modulus Z minus 2 plus I less than or equal to 2. So I'm going to start from here. This is A is less than or equal to 2 means 2 is greater than or equal to, right? So I'm going to start from here. I can say what is given in the question. Given 2 is greater than or equal to modulus Z minus 2 plus I. Now I want to write it in this form. So this is equal to modulus Z. I'm taking a minus sign outside. You will get 2 minus I, right? Because these 2 steps are equal. Now I'm going to apply this part. So this is you read from here, this is greater than or equal to, okay, I'm reading from here. The first one is less than or equal to second one, or second one is greater than or equal to modulus of outside modulus, okay, outside modulus you write. Then modulus of first one, so modulus of Z minus modulus of the second, modulus of 2 minus I, okay, so this inequality, the first part we are using. So that is equal to modulus of modulus Z minus root 5. Hope you understood this. Okay. Because modulus of 2 minus I, root of 2 square plus 1 square, right? 2 square is 4, 4 plus 1, 5. So we started with 2. So you are getting 2 is greater than or equal to, 2 is greater than or equal to modulus of modulus Z minus root 5. Now just you reverse it, write in the reverse order. So you can write it as modulus of modulus Z minus root 5 less than or equal to 2. Please listen, modulus Z less than or equal to 10 means Z lies between minus 10 and plus 10, right? Z lies between minus 10 and plus 10. So here what can you say? This lies between minus 2 and plus 2. Modulus Z minus root 5 lies between minus 2 and plus 2, right? So how can you write it? Minus 2 less than or equal to this, less than or equal to 2. So you take, we want to find the greatest value, right? So something should be less than or equal to 8. So take only this part. Modulus is at minus root 5 less than or equal to 5, sorry, less than or equal to 2. So from here you can say modulus z is less than or equal to 2 plus root 5. Okay, something is less than or equal to this one, less than or equal to that one, that particular value, or less than that. That means, and this is the maximum value, right? So modulus z is always less than or equal to 2 plus root 5. So that means modulus z can take at the maximum what? 2 plus root 5. So that 2 plus root 5, fourth one, that is your correct answer. Okay, so this is for greatest value. Smallest value means you take the other part. So from that you will get that answer. Okay. Now listen this 8th question. Look at this one. Here also they can ask least value or greatest value. Here some condition given, right? Under this condition, the least value of modulus is set. So for this type question also you can do in the same method, but there is some easy method to do this. Okay, so play any question of this type. So please listen very carefully how to do this question. Listen, I'll give the general result. Suppose, so look at this form, z plus 3 by z, right? Suppose modulus of z plus a by z equal to k, then whether it is plus or minus, no problem. Okay, only the format modulus of z plus a by z or minus a by z equal to k. Okay, same answer only. Then the least value of modulus z, that is the formula, and the greatest value of modulus z. Listen, how to remember this formula. Least value minus k plus root of k square plus 4 into modulus a by 2. In quadratic equation we studied one formula, right? Minus b plus or minus root of b square minus 4ac by 2a. Okay, something like that. Minus b plus or minus root of b square minus 4ac by 2a, right? Not exactly that, something, but you learn this. If you learn this, you can save time. So this is for least value. Greatest value, a small change. Instead of minus k, you write plus k, that's all. So what should be the formula for greatest value? K plus root of k square plus 4 into modulus a by 2. Okay, initially you may find it a little difficult, but you write and practice, you will find it very easy. Okay. So now please listen here. Any question of this type, you can do using this method. So modulus z plus or z minus doesn't matter. This is the formula, okay? And at the same time, you can find least value, greatest value, everything at a time. Only thing you have to identify the values of a and k. That's all. Then you substitute. So in this particular question, plus or minus, that doesn't matter, okay? So it is whether it is plus or minus, no problem. Here a value 3, k value 2, that's all. A value 3, here a equal to 3 and k value 2. So then what they asked? The least value they asked, okay? So the least value of modulus z is equal to, so I'm not going to write the formula again, minus k. So it is what? Minus 2 plus root of k square, k is 2, 2 square 4, plus 4 into modulus a. A is 3, modulus a means it is 3 only, 4 3s are 12, divided by 2. Now just simplify this. So minus 2 plus root of 16, right? It is 4 by 2. So minus 2 plus 4 is 2. So 2 by 2, your answer is 1, and that is option number 1. I'm sure this method you find very easy, right? So only thing you learn this formula, you can do the sum very easily, okay? Now let's move on to the next question, question number 9. Listen this question. If modulus z equal to 1, please listen here. Whenever you get modulus z equal to 1, you square both sides. Modulus z square equal to 1 square. 1 square is 1 only. Modulus z square can be written as z into z bar. Z into z bar equal to 1, right? Then what is z bar? Z bar is equal to 1 by z. Z bar is equal to 1 by z. Now take this expression, what we want to find. We want to find 1 plus z by 1 plus z bar. Numerator 1 plus z. Denominator is 1 plus z bar. Z bar can be replaced by 1 by z. So that is 1 plus z by, you take LCM z, so z plus 1. Right? 1 plus z, z plus 1, same, cancel. This z goes up. So your answer is Z, option number 1. Okay, now let's see the 10th question. The solution of the equation. Solution means you have to find the value of unknown, right? Here what is unknown? Z. Z is a complex number. So Z is equal to A plus IB or X plus IY. So X value, Y value you find out, substitute, you will get the answer, right? So now let us see how to find Z. For that you need X and Y. So what you do, put Z equal to X plus IY, put Z equal to X plus IY, then you know what is modulus is a root of X square plus Y square, just substitute here, X square plus Y square, then minus of Z, this is Z, so minus of Z means you have to change the sign, minus X minus IY equal to the right side 1 plus 2I. What we did, just we replaced Z by X plus IY, right? Now listen, two complex numbers are equal. Here two complex numbers, you got it, they are equal. When can you say two complex numbers are equal? The real parts are equal and imaginary parts are equal. So real part, the term independent of I, all these things, right? So root of X square plus Y square minus X is equal to 1. Real parts equal. And imaginary parts are equal, that's very easy, right? I coefficient minus y equal to, here I coefficient is 2. You change the sign, y equal to minus 2. So now please listen here. Y equal to minus 2. So minus 2y you have to get, right? Minus 2y. The last one, minus 2y is not there. That is not your answer. Here minus 2y is not there. Here minus 2y is not there. That is not your answer. Here only minus 2y. So this should be your answer, right? But for objective question, even this is enough. You get some value, okay, nobody wants to see the full answer and all, right? So, but if you have two places minus 2i, then you have to do further, right? If it is a 2 mark, 3 mark, you have to do the whole thing. Anyhow, I'll explain to you the entire part. Y value got it. Now to find X value, substitute here root of X square plus Y square. Y square means minus 2 square, 4. Equal to 1. Take this minus X to that side plus X. Avoid the root, squaring. When you square, root cancel, X square plus 4. Right side when you square, 1 plus X the whole square, A plus B the whole square. So it is A square plus 2AB plus B square. Both the sides X square cancel. 2X is equal to 4 minus 1, 3. You are getting X is equal to 3 by 2. So X plus IY means, so Z equal to X value 3 by 2. Plus I into Y, Y value minus 2. So your answer is 3 by 2 minus 2y. 3 by 2 minus 2y. Yes, okay, so first one is the correct answer. Now let's move on to question number 11. Very important question. In your exercise also you have a question like this, right? They can ask even in 5 mark. But now it is an objective question. So please listen very carefully how to do very easily this question. See, what is given here? Modulus Z1 is 1. Square it. Modulus Z1 square equal to 1. Modulus Z1 square means Z1 bar equal to 1. So what is Z1 bar? Z1 bar is equal to 1 by Z1. Same way, you take the second value. Modulus Z2 is 2. Square it. Modulus Z2 square is equal to 4. Modulus Z2 square means it is Z2 bar equal to 4. From here Z2 bar you find out. Z2 bar is equal to 4 by Z2. Now take the third value. What's the third one? Modulus Z3. Modulus Z3 is 3. So square both sides, modulus Z3 square equal to 9. That is Z3 bar is 9. So Z3 bar is equal to 9 by Z3. So find up to this first. Now, one more information given. This one they given, right? So it is given in the question, modulus of 9 Z1 Z2 plus 4 Z1 Z3 plus Z2 Z3 equal to 12, right? Yes, this is what given. They asked to find the value of modulus Z1 plus Z2 plus Z3. Now please listen here. The easy method is, here you take Z1, Z2, Z3 common. It is not common, but still you take Z1, Z2, Z3 common. So what is missing you write in the denominator, right? So 9 you write, Z1, Z2 you have taken, Z3 is not there, so write by Z3. Next one 4, Z1, Z3 is there, Z2 is not there, right? Last one, nothing, no number, 1 by Z1. So if you multiply and see, you will get the same answer, okay? Equal to 12. When you split everything, so modulus Z1 into modulus Z2 into modulus Z3 into modulus of 9 by Z3. Listen, 9 by Z3 is Z3 bar. Plus 4 by Z2, 4 by Z2, modulus Z2 bar. Sorry, Z2 bar. 1 by Z1, 1 by Z1 is Z1 bar. Equal to 12. Substitute the values. Modulus Z1 is 1, modulus Z2 is 2, modulus Z3 is 3. So 1 into 2 into 3. 1 into 2 into 3. Here you can write it as the whole bar you can give and you can arrange in order. Z1 plus Z2 plus Z3, the whole bar equal to 12. So cancel the numbers. 2 into 3 is 6. So 6 table you cancel, you get 2. So modulus Z1 plus Z2 plus Z3, the whole bar is equal to 2. You know modulus Z bar is same as modulus Z. When you take modulus of Z bar and modulus Z both are same. So you can say modulus Z1 plus Z2 plus Z3 is also 2. And so your final answer is 2. That is option number 2. Second option, right? So even the 3 mark, 5 mark questions, you can use this method. You can find it easier. Now listen to this question. Question number 12. Z is a complex number such that Z belongs to C minus R. So it is not pure real. And Z plus Z 1 by Z belongs to R. Belongs to R means pure real. Pure real. Something like this. No imaginary part. 0 I. I is not there, right? So when can you add two complex numbers? Imaginary part must get cancelled means. Suppose one is A plus IB means another one should be minus IB. Then only both get cancelled, right? So imaginary part sign should be changed. Then only when you add the imaginary part get cancelled, you will get pure real. So Z plus 1 by Z is R means Z is a complex number and 1 by Z you take it as Z bar. When you take Z bar, we change the sign of imaginary part. When you add, both get cancelled. So definitely you will get the real number. If you cross multiply, Z bar is equal to 1. Z bar means modulus Z square is 1. Take square root, modulus Z is 1. Question is, then modulus Z is, your answer is what? 1. Second option. Look at this question. Z1, Z2, Z3 are complex numbers such that Z1 plus Z2 plus Z3 equal to 0. Modulus Z1, modulus Z2, modulus Z everything 1, right? Modulus Z1 is 1. So when you square it, modulus Z1 square is 1. Z1 bar is 1. So Z1 bar is 1 by Z1. Same way Z2 bar is equal to 1 by Z2 because everything modulus value 1 only, right? Z3 bar is 1 by Z3. Okay, now with this idea, we'll try to do this. So they asked to find Z1 square plus Z2 square plus Z3 square. So you have to square it. So squaring. Z1 plus Z2 plus Z3, the whole square is equal to 1 square. 1 square is 1. So when you simplify, you are getting Z1 square plus Z2 square plus Z3 square. This is what we want to find. Plus 2AB plus 2BC plus 2CA. So you can say 2 into AB, Z1, Z2 plus Z2, Z3 plus Z3, Z1 equal to 1, right? So Z1 square plus Z2 square plus Z3 square. Like previous question, you take Z1, Z2, Z3 common. So what do you write here? Z1, Z2, so 1 by Z3 plus 1 by Z1. What is missing? You write 1 by Z2 equal to 1, right? So that is Z1 square plus Z2 square plus Z3 square plus 2 into Z1, Z2, Z3 into 1 by Z3. Please listen, 1 by Z3. What is that? Z3 bar. Plus 1 by Z1. 1 by Z1, it is Z1 bar. Plus Z2 bar equal to 1. So just 2 more lines. Only there is writing work. Z1 bar plus Z2 bar plus Z3 bar. If it is an objective question, see, I can say directly the answer. This is same as Z1 plus Z2 plus Z3 the whole bar, right? So, but Z1 plus Z2 plus Z3 value, they given us what? Z1 plus Z2 plus Z3 value, they given us what? 0. Not 1, it is what? 0. So, all these values are zeros. So, this part is 0. Then 0 into something, the whole thing is 0. So, you are getting Z1 square plus Z2 square plus Z3 square is also what? 0. So, the correct answer is the fourth option. But if it is a 3-mark question, you write the steps, everything. Okay. So, this part becomes 0. So, this is your answer. Now, let's move on to 14th question. If Z minus 1 by Z plus 1 is purely imaginary, then modulus Z. There are different ways to do this question. So, listen students, here they said pure imaginary. Pure imaginary means only imaginary part is there. So, real part equal to 0. So, one method is for Z you put x plus iy. For Z you put x plus iy. Then equate the real part with 0. You will get some answer, okay? From that you can find modulus Z. Another method, please listen. To check whether the complex number is pure real or pure imaginary, you find Z bar. You find Z bar. You find, if your answer, if Z bar is Z itself, you say it is pure real. If Z bar is minus Z, then you say it is what? Pure imaginary. So here they said this complex number, that is Z minus 1 by Z plus 1, I am giving a name for this, say I am taking it as W, is pure imaginary. Is pure imaginary. Pure imaginary means Z bar equal to minus Z. Here W bar is equal to minus W. W bar is equal to minus W. Please listen, W bar means you take the conjugate of this Z conjugate Z bar minus 1 by Z conjugate Z bar plus 1 is equal to minus of W. This is W. Minus of W means you change the sign. Only the numerator. Okay, change the sign. So you will get minus Z plus 1 divided by Z plus 1. Right? Now just you cross multiply Z plus 1 into Z bar minus 1 is equal to Z minus Z plus 1 into Z bar plus 1. Now just expand it. Z into Z bar. Z into 1 plus 1 into Z bar plus 1 into minus 1. Here by this minus Z you multiply minus Z bar minus Z into 1 plus 1 into Z bar 1 into 1. So you can cancel minus Z plus Z bar you cancel. So Z bar, bring this also here. So Z bar plus one more time Z bar is equal to 1. Minus 1 take that side plus 1. Z bar means it is modulus Z square plus modulus z square equal to 2. So you are getting 2 times modulus z square, right? 2 times modulus z square equal to 2. So modulus z square is equal to 1. Take square root. Don't write plus or minus because modulus value should be positive. So question is find modulus z only, no? So the answer is what? 1. So second option is the correct one. This is one method. I found this is little more easier for you. Okay. So practice this. Okay, look another question. If z equal to x plus iy, then the complex number is just to substitute the given condition z plus 2 equal to modulus z minus 2. For z you put x plus iy. So x plus iy plus 2 equal to x plus iy minus 2, right? Listen how to simplify this. First you arrange in standard form. Real part x plus 2 plus iy equal to modulus x minus 2 plus iy. So modulus means root of x plus 2 the whole square plus y square. Here also root of x minus 2 the whole square plus y square. To avoid the root, squaring both sides. When you square, root cancel. So x plus 2 the whole square plus y square equal to x minus 2 the whole square plus y square. Both the sides you cancel that y square. Now we expand it, a plus b the whole square, a square plus 2ab plus b square. Here a square minus 2ab plus b square, right? Both the sides you can cancel x square plus 4 you cancel. Bring 4x here, minus 4x bring to the left side, 4x plus 4x it is 8x equal to 0. So that means x is equal to 0. X is equal to 0 is the equation of y-axis, right? Y-axis only here we call it as imaginary axis. Okay, locus of z is x equal to 0. That is the answer, but they didn't say give the answer x equal to 0. X equal to 0 is the equation of y-axis. In organ plane we say y-axis as what? Imaginary axis. Okay, so your answer is the second option. So hope you understood all these things. The remaining sums I'll teach you in the next video.